Hello, welcome to our new seminar about my climate risk here from Argentina. I'm Leandro Diaz, Marisol Osman. We're both researchers in our center in Argentina for scientific research. We will be leading and moderating this seminar. For those who are not knowledgeable in climate risk matters, this is the setting. What do? We want to develop and integrate in climate science a bottom-up approach that is regional and that is context-based and allows to factor in the fit-for-purpose climate data and information. This is organized with a network of hubs, each one with a specific topic of science and work, but with a common purpose that is converging. To date, you can see the hubs that are in existence. There's only one in Latin America so far, but this might change as and when other hubs join us in the community. Let's look at the hub in Argentina. We are 20 students, teachers, researchers of various disciplines and institutions that work in order to generate relevant information and knowledge for the society. For a year now, we have been regularly meeting in order to coordinate in an interdisciplinary manner what we understand by my climate risk and what we want to do under that topic. Okay, today's webinar will be dealing about storylines or with storylines. We use this to deal with problems caused by climate change. But this concept is used in different contexts. We will be listening to two research experiences with two approaches to storylines as a way of generating knowledge that is socially relevant against the backdrop of climate change. Let's now introduce the first speaker, Julia Mindlin. She's a geophysicist, graduated from the University of La Plata, and she has been a student at the University of Buenos Aires under the direction of Carolina Vera and Professor Ted Shepard of the University of Reading. And as from August this year, she will be also teaching at the University of Buenos Aires. Her work focuses on the study of anthropogenic drivers of the Southern Hemisphere circulation, its impact on South America, and storylines. And she has had prolonged research stays at the Barcelona Supercomputing Center in Spain and the University of Reading in the UK. And there she carried out much of the work that she is going to be presenting today. She's also been a member of My Climate Risk Argentina, the hub, since 2022. By the way, should you have any queries or questions for the speakers for this first one and the next one, please post them in the chat for Q&A purposes. And now I hand over to Julia, please. Thank you so much for the intro, for your kind words. Let's see if you can see the screen, which I'm sharing. Yes, we can see it very well. Thank you. Okay, well, thank you so much for joining. First of all, I will be introducing you to work called Storylines on Climate Applied to Climate Services for the Wine Sector. We have worked along these lines with colleagues from the Barcelona Supercomputing Center and also my colleagues in the doctorate and obviously Mariluz Osman. What's the problem of wine growing and climate change? Let me deal first with a few technicalities before moving on to our research proper. Our work has been done in collaboration with climate services, colleagues from the Supercomputing Center in Barcelona. They have been working with users of climate information for the wine growing sector. You can see here a graph where the results of this work are summarized. And if you provide climate services specifically for this sector, you use various timescales. First, you have the weather forecasts in days or weeks, for example. These products can be useful for decision-making in the short term. And then you have subseasonal, seasonal, and also decadal timeframes. And last not least, you have a framework of 20 plus years. And that's what we refer to. Changes in this time scale do trigger situations that demand very specific action. And this is where we focus in our work. In order to have a general idea of how in this time scale climate change can affect wine growing, you can see what lies in store, what changes can be expected. For example, change in regional temperatures. So much so that at the end, region might not be apt for wine growing. There might be also changes in growth phases because the growth starts earlier in springtime, and also changes in precipitation that might also affect the health of the vineyards, and so on and so forth. So you might take also decisions as to whether you want to buy up new land, what kind of grapes you want to grow, or what the design of irrigation or drainage you want to set up. These are some of the decisions you might want to take based on the input we give you. So we are not going to work directly with the professionals of the wine growing industry, but we do work together with people who have had a long track record of generating knowledge as to these potential impacts and as to the decisions that should be taken accordingly. Now, what will be the first step in order to be able to translate the physical side of what we know about climate into actionable information for the industry? We do need to know about physical variables and realize whether there are indicators that are directly related to impact. So of late, we have come up with a new concept, the so-called FIICs in Spanish, that are the climatic impact drivers, things that are triggered by humans, drivers that might change a variable, its magnitude, its impact, a change in space, spatial magnitude of the impact of a given variable, and so on and so forth. So associated to these indicators, to these climatic impact drivers or FIICs, there is also the limits. That is the setting in which this variable might change without generating a given impact, and also from when on the impact will be felt. So on the left-hand side, you have the definition of these climatic impact drivers, physical conditions that are relevant. In this case, for example, using the example of temperature. So once we have identified the temperature, we can define either the mean temperature as a value of interest or the extremes of the temperature distribution range that can be translated into heat or freezing temperatures, and the transformation of information of the physical system into a indicator of interest is part of the process of producing something of interest. Now, this is the last very technical slide, but it's just to get us all on an equal footing. Here you can see the work tool that we use in order to generate information of climate projections. These are climate models. In order to be able to generate information of future weather, we use global models that are complex mathematical representations of the elements of atmosphere, soil, sea ice, ocean. And what do we generate with these models? We generate simulation vis-a-vis the future on the basis of a number of experiments where you can model using different concentrations, for example, of GHG, and try to find out what impact they will have on the climate. And this is being done in various research centers worldwide. We have a large set of experiments that inform with huge data amounts what we will be doing. But there is a hitch. Usually, the parameters are set differently, and this gives way to different answers, although we all use the same tool. So the question is, how can we deal with the existing uncertainty based on the tool that I just explained? So I was talking about uncertainty, and apart from the uncertainty in these models, there are other types of uncertainties. Basically, three types. First, what this forcing factor, the human driver, will be that is going to be impacting on the climate, and in turn will change our society and our emissions. So this is the first source of uncertainty. Secondly, we have the uncertainty of the climate system. As I explained before, how can we understand how the climate system is going to react? We do this using models, but since the models give different answers, there is an uncertainty that is associated to these aspects. And in the center picture, you can see to how large this uncertainty is. This illustrated by the yearly precipitations. And the dotted regions are the ones where actually information is available and represented. And you can see there are a few dots where people live. And thirdly, the natural variability that's part of the system and is associated to solar activity, volcanoes, atmosphere, and chaotic conditions in the atmosphere and in the ocean. So we can generate, run a number of iterations, the same model, and knowing that the results of each simulation is going to be different, we take the mean, and we know that this mean is going to give us the answer to the driver, to the forcing factor, but there's still the problem of uncertainty. So going back to climate services, if we provide a climate service, we do this as follows. First, you need to find out what are the climatic conditions that are going to be having an effect in each region, and what the climate events have been historically, in order to be able to understand. Then this is then used to co-produce, that is going to be users and researchers alike together, co-produce indices and empirical rules in order to establish safe limits and risks and ranges of value that are relevant in order to set up these FIIC, as I said, the climatic impact drivers I referred to before. Then we need to evaluate how the climatic conditions are going to change. There's a time scale, time and space, where we want to take the decisions and what are going to be the associated scenarios. And then we need to find out how we can best collaborate between different groups, users, decision makers, in order to better communicate the information and the associated uncertainty, and then also try and understand risks that correlate with the associated impact. So we're going to look into how climate conditions are going to change and how we can communicate this uncertainty and the corresponding information. And we're going to do this using storylines. So, up front, storylines is another way of relaying this information. We can communicate the uncertainty in a different manner, in a manner that can be useful for the purpose of decision making. Furthermore, we realize that storylines are very useful, but we have a prior large volume of information of what can impact the winery sector. And this is information generated in more traditional ways. Here you can see a snapshot of a paper by Cabré et al. Using these FIICs, the climatic input drivers. And the general conclusions were that this can crop up this can lead to new apt wine regions in Argentina, but there are things to be borne in mind.
First of all, the study was carried out with one single model. The problem with trying to establish climate data with a single model is that one of the major sources of uncertainty is the model itself, because this is not being communicated and it's not even being borne in mind. So in this analysis, with one single model, what researchers demonstrated is that for two different timelines and two climate scenarios, different climate scenarios, as you can see on the graph there, showing accumulated rainfall and precipitation during the growth period of the vines, well, we can see that there are different changes, various changes, but this clearly indicates, using the same experiment, that these changes may be very different as well. So what I'm going to try to show you is how we can approach this, how we can approach the uncertainty brought about by one single model, and to try to generate data and information that will be relevant and useful. So how can we generate information and data in a different way? And what's the difference between traditional methods and storytelling or storyline methods? The model we just saw tries to respond to the question, what is going to happen with these indicators and with climate? And we can give you an answer with one single model. However, the uncertainty is not being communicated. We're trying to deal with the problem, but we're trying to do it in a deterministic fashion, as if it were possible to just give one single answer. And we know, in fact, that that's not right, that we have limits to our knowledge, that we have differences between models which set differences to the outputs and the information that we can provide. The storyline method tries to understand that this is indeed a limitation and a source of uncertainty that we cannot simply rule out or limit. And it also tries to respond to another question: which are the adaptation measures that can be taken, bearing in mind the range of possible answers in view of climate? So we try to understand all these different answers that we see with climate change to try to generate information that despite the uncertainty will still be relevant. In the figure at the bottom of the screen, you can see the various sources of uncertainty and how they combine. First of all, we have the climate forcing uncertainty and global warming, and also the model uncertainty, which indicates how global average temperature might increase, what the dynamical conditions are going to be, the triggers, etc. We also see uncertainty in terms of how large-scale circulation is going to occur and what changes will occur when we look at climate globally, which might also give rise to uncertainty at a regional level. And we're going to look at that into more detail in a few moments. As you can see, uncertainty associated to climate sensitivity to drivers, to CIDs, and these, of course, combine at different levels of global warming. At the same time, these various levels of global warming will also tell us how regional temperatures are going to change and how we'll see a change in remote drivers, basically large-scale circulation. Now, with this data, we can generate information, basically bearing in mind these two very important factors, and we can understand what the possible impacts might be. Now, these, combined with knowledge of the users in terms of exposure, vulnerability of the sites and the sector, will allow users to adopt measures to prevent or to adapt to the possible climate impacts in the future. So, which are the major global phenomena that we are looking at, grosso modo? Firstly, climate change or warming creates changes in the tropics associated to major evaporation in the tropics and the increase of temperatures there. And this modifies temperature gradients around the world. On the other hand, we also see changes in surface ocean temperatures, which also might affect the region of interest, in our case, South America. And thirdly, we also see very large-scale changes in stratospheric circulation, which may also affect circulation in the Southern Hemisphere, and therefore our target region, South America. So these are three factors that you can see here on the screen, may have a different impact depending on the model that we are using. What we are trying to do is to try to summarize and to synthesize the uncertainty provided by each of these three major phenomena and to try to establish different storylines associated to possible potential changes that might occur at a large scale. And by doing so, this is what we come up with. We can come up with more than one storyline. Each is possible and potential, and each is associated to a combination of changes at a major scale or large scale changes. Here, we bring on board all the knowledge of the dynamics of the climate system, and in combination with our sector of interest, we can generate this type of maps that you can see on the screen to explain what changes will take place at regional scale in relation to changes at a global scale. Here you can see the different storylines. Each will show a different climate response, and this is the type of data that we're seeking to produce. So let's go back to wine growing and our target area, the region of the world that we're looking at. Here on the left is a map of Argentina and Chile. You can see the Andean mountains ranges there, and you can see a series of vineyards and areas where wine is being produced on the eastern side in Argentina or the western side of the mountain range in Chile. One important note for clarification here in terms of our method, when we use global climate models, we have an added difficulty. They have very low resolution, and in a region such as this, with very high mountains like the Andean mountain range, there are systematic problems in terms of generating data and information, especially in terms of temperatures, which are going to be determined also by the models. So it's important here to think about that. When we do global modeling or use global models, we have to apply an adjustment for this systematic error. So to give you a picture, wine production, as you know, follows a certain calendar and timing following the growing of the grape. Now, depending on the year of interest, we can see basically from September, October to May or June the following year. In June is when the vegetative cycle starts. There's an early, from January to February is when the grape grows, and then accumulation of reserves, and then before the harvest at the end of the summer. So March, April in the Southern Hemisphere. So this was our first step and the first challenge, in fact, in terms of climate sciences, because we have to work with this calendar, this schedule, and that means that we are forced to understand the large-scale phenomena that I explained earlier in these particular timescales. So which were the actual CIDs, climate impact drivers, that we looked at? After working in collaboration with our colleagues from Barcelona, who'd been working in the wine growing sector for a while, we identified a number of CIDs, climate impact drivers, which are relevant to the region for associated temperature, average temperature during the growing season, also degrees by day accumulated above 10 degrees during the growing phase, also maximum temperature during the growing phase, and also severity of winter, that is minimum temperature during the growing phase. And then there are 4 other indicators linked to precipitation and rainfall. One, spring rainfall, also during the summer, accumulated rainfall, and each of these associated to possible impacts. For example, the threat of pests or plagues, also making the harvesting period more complicated, and also exposure to more water in terms of irrigation. So I'm going to try to explain what we did to go from this global scale to the regional scale. We first realized that each of the large-scale phenomena that I explained earlier, the tropics, temperature in the Enso area and due to El Nino or changes, stratospheric changes, these all may generate changes in the future in terms of circulation in the Southern Hemisphere, which is what you can see on the screen on the right. Here we show the changes that we saw in winds, for example, in terms of these climate impact drivers. And each of these changes in circulation also bring about changes in each of the indicators or the CIDs. Here we're looking at summer rainfall, for instance. So what you can see is that each of these driving forces or triggers will create changes in our indicators. And when we analyze how they may change throughout the seasons, we see a major uncertainty, and that is because of the model, as I explained at the very beginning. We can see that each of these large-scale impacts may have a range of values. You can see that here, these range of dots or points. So here we want to generate storylines. We try to summarize the uncertainty and complexity of responses and try to summarize them into 2 responses, which basically capture the most extreme changes that one may expect. So on the one hand, we have the red dot. On the other hand, we have the blue dot, and each of these basically captures the 2 extremes of possible responses in terms of the large-scale response. I'm now going to try to explain how we can generate information regarding possible changes in relevant indicators for the wine growing sector under these two possible storylines. And this is how, using the storyline methodology, we can deal with uncertainty brought about by models. So how do we generate this data? What you can see on the screen now are the 4 CIDs, or indicators associated to temperature, and how the indicators may change according to one storyline or another. Remember, the red dot and the blue dot, each storyline shows the extreme large-scale response, and I'll refer to them as the storyline for weak warming in the tropical Pacific, which brings about a very specific change in the stratosphere and so on, and also the other extreme, high warming in the high tropics. So what you can see here, the upper part shows maps showing changes with higher values, significantly higher values in terms of degrees day, maximum temperatures, also higher average temperatures, and a distribution of higher values in general in the minimum winter temperatures. In the bottom part of the graph, you can see that the storyline, the alternative storyline, presents us with minor changes in accumulation of degrees by day, also minor changes in terms of maximum and minimum temperatures, and greater changes in terms of the minimum temperature during the winter season. So we see that there is a lot of complexity associated here. Now, by taking this approach, we can come up with some relevant information. The same here for rainfall. It's quite impactful to see here that under the storyline of weak tropical temperatures, we can see very minor changes, top part of the graph, whereas in the region below, we can see how rainfall drops. But the alternative storyline shows an increase in precipitation in large part of the area and smaller changes in the southern part. So this quite clearly illustrates how uncertainty of models allows us to show quite clearly, in fact, which is the uncertainty that we have to deal with when we want to make estimates in terms of long-term changes associated to climate change. So one way to summarize all this information is by using this type of maps that you can see on the screen. Let me try to explain. This figure here looks a little bit complicated, but it's quite easy to understand. Each of the panels or tables here shows a different climate impact driver. Above, precipitation in the spring season and the harvest season, that is early autumn, and the two graphs underneath show accumulation of degrees day and also severity of winter. What they show in terms of, or on the horizontal axis, are the various degrees of global warming since 1950, average temperature until 1979. As you can see, there is a change in the indicator in terms of an increase in the average global temperature. As to the y-axis, or the vertical axis, we show, starting from 0 here, any changes in the indicator as we approach high tropical temperatures. That storyline, remember my earlier slides, showed the one associated to the bottom graph. And below 0, we can see how the indicator changes when we approach the storyline of weak tropical warming. And the dotted line shows the value that is reached when we reach the value of the storyline that I showed you in our earlier maps. So basically, this graph here if we stop at any of these points here, or at any part of this map, we can understand the changes that are taking place with the various indicators under the same storyline. That is basically the same large-scale response, and also regarding a certain level of warming. Finally, important to note this dotted line here in blue, which indicates standard deviation in terms of variability, natural observed variability. That is a first approach for us to understand how major are the changes in terms of what we are used to seeing. For example, if our world increases its temperature by 3 degrees, and with a storyline of the tropical Pacific warming, a high tropical Pacific warming, we can see clearly that spring rainfall would be in the range of natural variability. We'd see higher precipitation and rainfall, but within the natural variability that has been observed during this period, 1950, 1979. As to degrees day, we can see a number of dotted lines. Each of these are associated to changes in the best grapes to be grown, and this line here shows variability. So we can see clearly that in this particular region, as from higher than 3 degrees of temperature increase, then wine growing would not be feasible. So let's look at these maps, but let's take them in terms of pairs of regions. Here, for example, Casablanca and Yucca, we can see that we can link various degrees of temperature increase in the storylines, and we can associate them to changes in the indicators. Here we can assess how they would change, how the indicators would change in more than one region. So this graph shows us the same storyline and how things would change simultaneously from the side of Chile and the side of Argentina, how conditions would change for wine growing.
Here we have another example further south. The Biobío Valley and Sanyal. On the side of Biobío, the selected storyline shows very minor changes in precipitations in springtime and also during the harvest time. But on the side of Argentina, in San Patricio del Chañar, the same future scenario would show well, a low increase, but increase of precipitation during the seasons. And the same can be said regarding indicators associated to the temperatures. So this type of information helps the user consider a number of options regarding the future, and against the backdrop of these changes, might opt for adaptation strategies that are flexible enough in order to adapt to all the potential future scenarios. So how do we integrate this information? Well, co-producing information based on the identification of relevant impacts in order to give answers to questions such as in which regions can we produce wine of a given type of grape in the future, and could new wine growing regions come up? And additionally, you can also put uncertainties into a given context. For example, when are certain risk limits going to be reached? Well, regarding a given magnitude of temperature increase in degrees, and thus we can link this up with emission scenarios. That is the other source of uncertainty, in order to define when a given level of warming is going to come about. Then you can also distinguish between regions of more or less uncertainty, because sometimes the differences between storylines are more marked in certain regions than in others. So, in conclusion, the conditions might be good for wine growing or even improve. We have seen this based on prior science, but now with our models, we also are able to clarify the information and based on data provided by global models, we realize that we need to downscale to zoom into the local level to be able to factor in very relevant facts that are local, and then also factor in changes, for example, regarding the start of growth, of the growth phase. So, in conclusion, storylines are a robust tool in order to analyze changes in the long term. You can evaluate, assess, and deal with the uncertainties in the models, and you can also answer specific questions. For example, what can happen in different regions at the same time. And then the work with stakeholders is of the essence in order to come up with information that is relevant and useful for people who have to take the decisions. Thank you so much, Julia. That was most interesting. Be reminded that you can pose your questions in the Q&A part of the chat. Do not use the chat, please. Only the Q&A part. And now we're going to be listening to Florencia. She is an anthropologist with a specialty in social cultural aspects and social anthropology. Graduated in San Martin University. She is a member of the program of the San Martin University, and under the Professor Valeria Hernandez since 2008, she has been participating in interdisciplinary and intersectoral research projects, ethnographic field work regarding climate change impacting the south of Argentina, development models, sustainability, and she is currently the coordinator of the working group on knowledge co-production in the climate project. So over to you, Florencia, please go ahead. Hello, everyone. I'm going to try and share my screen. Let's see if it's coming up. Can you see what I'm sharing? Okay. Excellent, thank you. What am I going to tell you in the next minutes? Well, it is a result of an interdisciplinary work undertaken by a number of climatologists, researchers, and anthropologists who also participate in the Regional Hub My Climate Risk in Argentina. They work in the conceptual in the Institute on Climate Impact and the faculty of La UVA and the snowfall and rainfall and climate changes faculty of the university in Argentina. So in my case, I'm part of the work undertaken at the university, and the doctor who is leading my work and supervising it is in the French part of this work. So, as you can see, these are different academic disciplines with various baselines and methodologies. And what we intended from the very beginning was to aim at an interdisciplinary approach to deal with climate storylines that are used or managed in various stakeholder groups. So let's define. Interdisciplinary means that coming from various fields of knowledge, we do tap into the potential, but without limiting ourselves to a single theoretical setting. So we've had a number of monthly meetings where we have been going into the various definitions, how we go about dealing with storylines that are climate related in order to set up the setting and the backdrop of our common work. All the authors of this work are experts in the South American region, the so-called region according to the CESA terminology, and we are focusing specifically on Argentina in this case. So we had a common interest and wanted to deal primarily with drought. That is very relevant for this region. And specifically, we wanted to deal with the years 08, 09 in the northeast of Argentina. And why is that? Because it had a lot of impact in the farming sector and in the livestock sector. Remember, Argentina is the first flour and soy oil exporter, and the third in wheat and corn. So this drought brought about a drop in 30% of the output in the sector. Livestock were lost, harvests were lost, some glens dried up, and the level of the rivers, especially in Saladillo Amargo and in Saladillo Dulce, dropped dramatically. Apart from this impact, I mean, we have the anthropological side and the climatic physical side. So we had enough data in order to draw on two different viewpoints when talking about scientific fields. We used various hydrometeorological variables based on in situ and also satellite data, reanalysis of data, but also ways of responding to climatic variability. And on the other side, we had a time frame from 2009 to 2012 to gather and draw upon data. So this meant continuous work throughout the year 2009 in order to record all the data and events during the dry season. And then in the last 4 years, we have been able to plot the use of land, the agricultural calendar, and to what extent climate changes have impacted farming activities. We have generated a number or created a number of workshops with stakeholders and have been able to record day-to-day information about the day-to-day activity of the relevant actors. So this large amount of data feeds into our storylines. And why storylines? Why not another method? Well, in social sciences, there is a strong consensus regarding the role of storylines when creating a social feeling and way of thinking, and when it comes to dealing with problems and to taking decisions. On the other hand, the climate community, as Julia already explained, has the opportunity of using storylines in order to deepen the knowledge of these matters, the climate knowledge and certain uncertainties related to physical events, so that we go from the predictability to the decision-making part of the equation. So these are two communities of academia that are willing to share and to collaborate so that we can generate a common body of knowledge that will allow for mitigation and transformative action to take place. So, first, we realized that there was an important contrast between the different approaches. The experts in climate had been using the storyline argument, the narrative, if you want, depending on what kind of theory you're resorting to. But at the end of the day, here you focus on the physical coherence of what you are telling. The storyline needs to be coherent with the cause and effect related to a specific climatic event. And this approach gives a priority to the coherence, the consistency of what the storyline tells us, and the physical dynamics, the physical part of the equation. So you need this to be consistent. And why do we insist on this logic? Because it is key in order to be able to convey the message. And furthermore, this methodology of analysis and communication using storylines allows us to reach a common vision whereby everyone involved is able to realize the vulnerabilities inherent to the system. Julia already explained this, not only the storylines, but also the systemic vulnerabilities related to various scenarios of climate change and variability. Furthermore, this setting, although it focuses on the physical part, can also be translated to a multidimensional space. And this is a major change, because this allows us to relate the physical dialogues to a more ample space. Now, seen from the viewpoint of the anthropologist, that is us, we start with the narratives, the storylines of what is the narrative of the social history. And I'm not going to go into details because that would mean going through 200 years of knowledge, but there is a link available in the Hub's webpage if you want to know more. But just let me say that we anthropologists that are involved in this work, we see this through linguistics and the hermeneutical sociology. I mean, there's all this body of theory that is underlying. And these premises, these assumptions, say that storyline is only one dimension of the narrative, of the story, because a story becomes a story once you tell the story to another person in a given context. And that's why we say that stories are essential to create a social construct and to be able to create relations between people. Always bearing in mind that there are different perspectives. When we deal with a story, we don't only concentrate on the logical organization of a number of events that happen along a given timeline, with always a cause and effect relationship, which gives the story its inherent consistency. But we look at a double organization of the story. On the one hand, you have the timeline organization-wise, but then the way you select this chain of events also is linked up with the social organization that comes to pass as soon as a person starts to tell, to refer a story. It has to do with who is telling what and in which context.
This is never arbitrary or logical. It has to do more specifically with a social configuration. Basically, the sense of the story can only be understood. It can only be understood in terms of a context, and that is why the relevance of storylines from the social perspective of stories not only has to do with what the story says and tells us, but also what they do to people. That is what we, as from Austin and ahead, we've called that the paraformative nature of stories. That is their ability to have an impact on social life. For example, giving values to people, reinforcing the status quo, or calling into question the status quo, or questioning power relationships. So basically, these stories bring together a number of lines of significance that basically show that there are power relations, social structures, and their relations of power. So from this vantage point, we not only work with the discourse itself and the narrative, we don't see the context as an epiphenomenon. Basically, the context is what gives significance to the story itself. So with these two very different views, we decided, as I said earlier, not to try and force a merger into one single framework. We decided to respect these 2 points of view, but we do need certain consensus to try to understand how we can establish a dialogue between them. So we established a very broad definition of a storyline. Basically, we say that it's a description of events that has a beginning, a beginning, an end, and that they always tell the story of past, present, and future stories. And this is very common. We see it in anthropology and climatology literature. So on the one hand, we wanted to identify stories from the climate community and also those identified by the anthropological community to understand the values that were being interpreted in terms of the event, what are the spatial coordinates as well in each of the storylines, and what elements and processes are being attributed with a causal role. I'll be explaining that in more detail, in fact, because that was a big topic. Finally, also, we wanted to pay attention to the action lines of each of these stories. Why do all of this? Well, because all of us wanted to try to identify how the various storylines which help us understand and identify how the various stories help us to see, to listen to different arguments. So we wanted to bring together these two storylines without forcing them to try to understand and interpret the events in its multiple facets, to try to understand what are they telling us? Who is telling us the story? What are each of the actors in this story telling us when they talk about drought, for instance? So each group identified the stories. All of them were analyzed in a symmetric fashion. That is, they were all understood to be equal in terms of their we didn't think that one stories were wrong and others were right. We tried to understand precisely what are these stories telling us with regard to this particular drought event. It was very important for us to pay attention to the causes of the event and the possible courses of action that could come up from each of the stories. Now, from the climate point of view, and I won't go into depth in this, I won't go into depth in the climate side or the anthropological side. I just want to show you what the interdisciplinary dialogue is about. But I do want to say that the climate community, as Julia just explained, obviously understands that the most important are the climatological facts, hydrology, rainfall, etc. And on the basis of physical indicators and also scientific literature, they identified 3 types of drought events, one caused by weather, another by hydrology, another the farming and agriculture drought. You can see that on the left of the screen. And then they looked at possible triggers of that event, of those events, following the storyline method, as Julia just explained. So I won't stop there. I won't go into detail in that because Julia just explained it. So after identifying the possible triggers of that event, they included natural factors and also man-made factors, more greenhouse gas effects, use of land, deforestation, and so on. Now, under this logic, we saw a story that came up with a tree of reasons, of causes. You can see that on the right of the screen. And this falls in line with prior literature regarding the physical dynamics of each of these events. And this is based on a matrix of a concept. You can see it in the graph with circles and semicircles, parts of the system that are interrelated and intertwined in a multidirectional fashion, bringing cause and effect together. And these are attributed to each of the factors regarding that particular drought event. The lines that you can see, the dotted lines, indicate causes and effects where we don't have sufficient scientific evidence to affirm that there is a causal or a cause that can explain it, at least until now. As to the anthropological community, we worked with a theoretical framework, a hermeneutical framework, as opposed to the climate community. Here, it was social structures and people who came to the forefront instead of climate factors. Now, on the basis of all the data that we were able to compile, we found that there were 3 factors. On the right of your screen, you can see the photographs of each of the people that I'm going to describe very, very quickly. On the one hand, it's important to bear in mind that each of these stories, or the difference between them fundamentally, is that they change radically depending on the position of each of these people in relation to the economic production model, transgenic or MGO soybean production, for example. Over the last 30 years, Argentina has really embraced this productive model. And this was not an exception in our study. Now, in terms of this drought event, those mainly affected were, of course, farmers and farmers, basically. For them, their story about this event was very different, both in terms of attributions and also possible actions, was very different, as I say, to the story of environmentalists or the political world. And this is important to note because this drought event took place during a very specific social period. On the one hand, there was a commodity prices were going up at the very beginning of 2008. A ton of soya was $600 a ton. In that context, the national government decided to propose a measure to increase taxes for export duties and levies, which was understood or called as the 125 tax, according to the law that passed that tax. And it was resoundingly rejected by the whole farming sector because they didn't want to pay the tax. So they started to organize picket lines, protests for 3 months. So the government was basically forced to drop that measure. As a consequence of all of this, and in that context, we were seeing the drought and also these rural protests. In the second half of 2018, these prices started to drop as a consequence of the economic crisis, the financial crisis in 2008, which also meant a drop in the prices of commodities. So this drought event was interpreted by these people. Remember that they were suffering all of these various factors. So it's really important, let me stress this, that the context is not an epiphenomenon. It's fundamental to interpret events. So for farmers, the drought event, yes, was seen as a very important event, but it had major impacts in their production. But they made the government responsible, not the climate, because this was natural variability of the climate. But they understood that the fault lay with the government. And so basically they said, well, our action has to be on the economic front. We want subsidies, credits, or exemptions, tax exemptions. Now, in terms of the political authorities, who should have tried to face the challenge and the claims of farmers, whether they be small, medium-sized, large, and different producers, livestock farmers in general. Well, the drought, although it was due to climate variability, the political community understood in their storyline that it didn't affect everybody equally. They basically claimed that the small farmers had a greater impact than the major farms, who for them were the people responsible for the drought, because they associated the drought to private use of water, deforestation, and other factors. So for them, it was also important to get subsidies, tax exemptions, or other types of loans and credits. Another story is that of the environmentalists, or in our area of study, environmentalists claimed, well, no, this drought event has to do with an environmental global crisis. For them, the attribution is directly linked to too much growing of GMOs, which again means deforestation, changes in the use of land, channeling private water, excessive use of chemical products, etc., which for them, for the environmentalists, had everything to do with the drought event. And for them, it was basically a driver of climate change. So the action that they demanded was a political one in their storyline. They said, we have to call into question our production and consumption model. So we have 3 very different storylines here with very different actions and consequences, and they clearly reveal that the way in which people interpreted this drought event has a lot to do with the context and the place where each of these social actors, the place they have in the social structure. Now, we have two very different results, as I've explained. So we try to understand how can we establish a dialogue here? How can we find points of agreement, of convergence? And we came up with a number of conclusions, which I'm going to share with you. Basically, we didn't want to force having one single framework, as I explained earlier. So this allowed us to respect the multiple arguments, the multiple contexts of these stories. In doing so, we realize that both in the logic of discourse and also graphical representation, the story of the climate community puts on the table a way of understanding human activities which always come second in an abstract form. I can go back if you like. So the climate community leaves them on an abstract plane. For them, the priority is physical coherence and consistency of premises and conclusions. In doing so, they seem to go far away. They zoom in too much and they don't understand which are the specific people who take decisions, which are the social structures where those people are immersed. And of course, they lose sight of the production and consumption model, the geopolitical situation, international relations, political projects for development as well. All of these issues are determining factors and are as important as climate change and variability in terms of looking at future actions. Secondly, from another perspective, we wanted to understand how do each of these stories come together in any way. We saw that the environmentalist story is very closer to everybody's heart. It's close to the climate community as well. The environmentalists were the only ones who could include in their horizon, in their forecast, the global environmental crisis. But from the climate position, attribution cannot be understood in the same way as for environmentalists. Environmentalists interpret attribution or who is responsible for the climate community. Clearly, it differed greatly from the environmental community. And as we saw here, for the climate community, there were factors that had been indicated both by the political community and the environmentalists as responsible for the drought. But the climate community said, well, there isn't enough evidence to say that this drought represents climate change. More, it can be interpreted as natural variability of climate. I'm not saying that I'm not trying to call anything into question, but certainly, as we can see in the dotted lines, there is not enough scientific evidence to claim that there is a direct relation between those variables that the environmentalists pointed to. So we understood that we had a very enormous scientific gap here in terms of scientific knowledge, both social and climate knowledge. And my last point, basically, that we focused on for this interdisciplinary dialogue was the relevance of the plurality of contexts, the plurality of disciplines and non-academic knowledge in order to try to get a better understanding and a more sensitive understanding of the drought event and the various actions, social actions that could be put in place. On the one hand, to say that only the physical context makes sense without bearing in mind the position of people, well, sometimes that leads you to not paying attention to other factors that are key for local disputes and settlement of local disputes and for transformation towards a more sustainable world. However, if from the social aspects we don't look into the physical dimension, then we could also go into unfairness, an unfair interpretation, because we are not paying attention to the scientific data that we need to look at to try to debunk a position. And we could also run the risk of saying, well, these discussions are basically political, or we could make environmental or physical aspects become political. So by way of conclusion, we need to be able to establish an interdisciplinary dialogue. And this allowed us to come to a series of conclusions, which I will explain very briefly. Basically, and firstly, that there is no theoretical model or proposal, one-size-fits-all models, but that interdisciplinary dialogue is key to be able to complement the different perspectives and views and to identify arguments and factors that may condition and determine transformations and possible alternatives towards a more sustainable and socially just horizon. We need to bring on board the voices of social actors in order to construct relevant climate information in order to conduct climate action. And that's all from me. Thank you very much for your attention. I'd be pleased to answer any questions. I'm not sure I went over time. Thank you very much, Flor. That was an excellent presentation. And let's very quickly start with our questions. One for Julia from Daniel Ratila.
Que dice, hi, Julia, thank you for the presentation. Not sure if I missed it, but how do you set the boundaries for the extreme you look at for the storyline approach? And also, what are the biggest challenges you encounter when exploring the storyline approach? Thank you.
Okay, should I answer in English or Spanish? English, right? Yes, English, okay. So thank you, Daniel, for the question. Yeah, so the extremes, I understand you're talking about the extreme values of the large-scale remote drivers. Those are selected by looking at the changes under all the plausible combinations of remote driver responses. So in this case, for example, we had 4 remote drivers that would lead to a large space of storylines. If you want, if you select 2 extreme values for each driver, then you would have 16 storylines, 16 combinations. And so looking at the FIIC, the climate impact driver responses under each of the storylines, we selected the extremes based on precipitation, because precipitation was most responsive to the uncertainty in circulation. And so, yeah, that's how we find the two extreme storylines. So they're really mapping the extreme driest and wettest, for example, response in the areas of interest. And then a big challenge is to really when applied to a specific climate service, I think the biggest challenge is to really understand what information will be relevant from the beginning, really know which are the climatic impact drivers that are most relevant, and then understand the limitations of the tool that you're using. So for example, we're working with global climate models, and although there could be relevant impacts associated with daily timescales, or I don't know, deep convection on a daily scale, we have to understand which are the limitations, what are the questions that we cannot answer with the tool that we're using.
Thank you, Julia. There is a question in the Q&A section for Florencia. Carolina asks whether the interviews to the 3 stakeholder groups has been undertaken after the drought in 2010, or whether these interviews were conducted later, because possibly in the intervening years, viewpoints have changed as to the origin, and maybe the man-made drivers also play into this. May I answer? Yes, thank you, Carolina, for your question. Actually, the interviews with farmers and stakeholders from the administration and environmentalists. About 80 interviews were conducted, and they were done in 2009. And in the ensuing year, there were floodings and there were other settings for the interviews. But the climate change issue hadn't been factored in by these actors at the time of the interview, that is 2009. Obviously, there has been a shift, and a major shift, obviously. And then there is another question for you. Pilar González asks, the analysis of the storylines as reflected by the traditional media. Have you looked into that? That's an excellent question. In my doctoral thesis, actually, which I presented in 2013, I dealt with this, among other things. Initially, we wanted to analyze the media, and we had followed up what the media outlets said at a local, regional, and national level. So this will be work for the future. Excellent. Now, a question for Julia from Pablo Borges.
Para Julia, de parte de Pablo Borges, que pregunta, Julia, who is using this information and how?
Okay, thank you for the question. For the moment, no one is using this information yet as such, at least no one from the actual viticulture sector. We are working on a publication on this, and then eventually I would like to prepare a report that is in Spanish and usable for Chile and Argentina. However, the main goal of this work was to first test how the storyline approach could be used in a climate service problem. But given that we found that there's relevant information to communicate, it would be good to create a report on it.
Leandro, you're muted. Sorry. Thank you, Juli. We have another question for Florencia, Ted Scheffer.
Otra pregunta que hacen para Florencia, de Ted Scheffer. Florencia, it seems to me that your critique is not so much of physical climate storylines, but of physical climate science itself, as represented by IPCC Working Group 1. Compared to traditional climate approaches, do you think that physical climate storylines can help interdisciplinary dialogue between physical scientists and social scientists? For example, storylines do not need to require proof. In the concept you talk about for your drought example, but rely instead only on
I'm going to answer in Spain, Ted, unless you would prefer to have an answer in English, but we could do that in writing through mail, for example, but in Spanish now. Actually, I don't think this does cancel each other out. The interdisciplinary approach and the storylines hold a lot of potential. Actually, I don't know if my message came across fully, because I'm actually a very speedy speaker, but this is a matter of complementarity. Let's not forget the physical part of storytelling, of the narrative, because there's always another side to consider, and definitely there is a lot of complementarity here that comes into play, and it doesn't cancel each other out. And I do like very much what you said at the end of your comment. Actually, the physical storylines are based on plausibility. They're not based on empirical evidence. And something that we thought was very stimulating and interesting in our work is that with this way of working, we can use the episodic memory and based on something that has happened in the past, have an outlook vis-a-vis the future that holds a lot of potential. And thanks to this, we were able to comprehend the limits of the knowledge proper, and that with this way of approaching the whole, we broadened our perspective. Thank you. Last question. Alejandro Lopez asks, in terms of storylines and social analysis, have you included the social storylines of the climatologists? Because the storyline of the climate experts is used or factored in as a physical part, but there is also a social component to it, isn't it? Excellent question. Maybe I just tiptoed over it, but I'm going to drive this message home now. Both sides, climatologists and anthropologists, had a premise, an assumption. Everything in our communities was going to be considered a storyline. We set up two disciplinary storylines. The anthropologist building on what people told us in the ethnographic field, and in the climatology side, what physically could be brought about. But then we have Laura Rey, who has been working during the same timeline with an analysis of the climatological community, and Dr. Fernandez and myself have also dealt with this topic, but this means a shift in the goal of the analysis. In our work, we wanted to pinpoint the commonalities, but also the differences of our various disciplines of knowledge. Okay, let's wind up. We're coming to a close. Some of the questions that were posed were answered directly in the Q&A part of the chat, and some questions remain pending, but maybe Florencia can answer them now. But let me, in closing, say thank you to Florencia and to Julia for their presentations, and thank you so much, everyone, also for your active participation with these extremely interesting questions. So, in closing, let me remind you that this is part of a number of webinars dealing with climate stories and uncertainty, and we're going to have a new seminar coming up, 23rd of August, Sources of Climate Information, How do our values and context influence our choices. So just a heads up, this is the next seminar, a webinar coming up. And thank you very much, and thank you for joining. Have a nice rest of the day.